For decades, the story of a dementia diagnosis has started way too late, usually only after memory has already started to fade. Well, today that entire script is being flipped. We are right in the middle of a massive revolution in how we find this disease, not by its symptoms, but by its hidden biological fingerprints, sometimes decades before it even surfaces.
We've all been taught that dementia begins with memory loss, right? Forgetting names, misplacing keys. But what science is showing us now is that that's actually just the tip of the iceberg. It's really the final act of a story that has been silently playing out inside the brain for years.
And just how long is that silent period? Take a look at this timeline. It's pretty shocking. The very first biological signs, these toxic amyloid proteins starting to build up, can show up a full 15 to 20 years before anyone feels a thing. Then, maybe 5 or 10 years after that, another protein, tau, starts to form these destructive tangles. All of this damage is happening completely under the radar, which is exactly why finding it early is so incredibly important. So, the big question is, how on earth do you find these invisible clues while they're still hiding? And that brings us right to the heart of this revolution, the science of finding the disease's fingerprints and figuring out what they're telling us. The key to all of this is something called a biomarker. The best way to think of it is as a biological fingerprint. It's a real, measurable physical sign that gives doctors a direct window into what's going on with the brain's health. Simply put, biomarkers make an invisible disease visible. And where can we find these fingerprints? Well, it turns out researchers have a whole new toolkit. They're able to pull clues from our blood, from the cerebral spinal fluid that cushions our brain, from really sophisticated brain scans, and even, this is the wild part, from the digital signals we create every single day.
All right, so let's open up this new toolkit and take a look at how each of these parts works to give us a much clearer picture of our brain health. Okay, so what's the most transformative part of this whole new toolkit? Without a doubt, it's the development of simple blood tests. This is a massive leap forward. We're talking about something that could make screening for Alzheimer's as routine as getting your cholesterol checked.
So how accurate are we talking? Look at this number, 93%. One of the leading blood tests, which measures a version of that tau protein called p-tau217, has hit a peak accuracy of up to 93%. I mean, for a simple blood draw, that is just remarkable.
And to put that number into perspective, this chart compares the blood test's accuracy to an amyloid PET scan. Now, that's a really complex, expensive brain imaging procedure that used to be a gold standard for diagnosis. And as you can see, the simple blood test is right up there, nearly as accurate.
Now, for years, the absolute gold standard for this kind of detective work was a test of your cerebrospinal fluid, or CSF. And yeah, it's super accurate, but it requires an invasive lumbar puncture, a spinal tap. The new blood tests, they offer comparable, sometimes even better accuracy, but with a simple, routine procedure. This right here is the game changer that makes widespread early screening actually possible.
Of course, brain scans, or neuroimaging, are still a super important piece of the puzzle. Amyloid and tau PET scans can let us directly see the plaques and tangles building up. And at the same time, a more common MRI can show us if the brain is shrinking, which is a key sign of damage, especially in memory hubs like the hippocampus.
But the toolkit doesn't stop with what's going on inside our bodies. The next frontier, and this is where it gets really futuristic, is digital biomarkers. This is all about using the technology we carry around every day to pick up on tiny behavioral changes that could signal cognitive decline, long before we would ever notice them.
Seriously, think about it. AI can analyze our speech patterns for tiny hesitations or changes in the words we use. It can track our typing speed and how many mistakes we make on a keyboard. It can even detect subtle shifts in our gait, the way we walk, and analyze our sleep patterns through a smartwatch. These are all digital fingerprints that could give us an early warning years before a person would ever think there's a problem.
Okay, so here's the crucial point. Doctors don't just use one of these tools by itself. The real power comes from combining them to build a complete biological picture of what's happening.
And to do that, specialists all over the world use a system called the ATN framework. It's just a way of classifying the disease based purely on biology. A is for amyloid, so you check for plaques. T is for tau, checking for tangles. N is for neurodegeneration, which is looking for any evidence that brain cells are injured or the brain is shrinking. Put them all together, A, T, and N, and you get a complete biological signature of the disease in any one person.
So all of this incredible progress is really pointing in one clear direction. The future of dementia care is early, it's going to be accessible, and it's happening right now.
So what can we actually expect to see happen in the next 3 to 5 years? Well, experts predict that these super accurate blood tests are going to start replacing those expensive PET scans for routine clinical care. We're going to see AI-powered screening tools pop up in our primary care doctors' offices, and this idea of continuous passive monitoring of our cognitive health through our wearables, that's going to become common.
And this brings us to one final, really powerful question. What happens to medicine, to our society, to our own lives, when we can screen for the risk of Alzheimer's disease 2 decades early, as simply and as easily as we screen for high cholesterol today? That is the world this biomarker revolution is busy creating.